Hello everyone, in this tutorial we are going to take a look at how to create a fluid simulation using Obi. So the first thing that we need in our scene is an Obi emitter with solver. So here's our emitter, and if we clicked play right away we would see some very ugly particles falling, nothing very exciting. So let's take a look at how we can improve the look of this. The first thing I'm going to do is I'm going to reduce the radius of my emitter because it's probably too large. And the second thing that I'm going to do is increase the speed at which particles are being emitted in the direction of the arrows here. So this is the speed in meters per second. If I change it to say 3, particles will be emitted with more intensity, and also more particles will be emitted per second in order to avoid gaps in your flow. Okay, this is handled automatically by Obi, so you don't have to worry about that. The third thing that we must do is give our emitter a material. Okay, the emitter material is an asset that contains all the physical properties of your fluid, such as viscosity, surface tension, or density. So it pretty much defines the physical behavior of your fluid. I'm going to go ahead and create one. Create Obi material fluid. There's another type of material here which is used for granular materials such as sand or gravel, but for now we are going to use material fluid, and I'm going to give it a name like water. And just by dragging this material we just created to the appropriate slot, we can see an improvement in the behavior of our particles. They no longer clump together when they get out of the emitter. And before we go any further, I'm going to first of all change the color of our particles to something more visible, and I'm also going to create a plane, a collision plane, so that we can see particles interacting with something in the scene. So I've just created the plane and I'm going to drag it to the Obi Collider group here. Also very important, do not forget to change the layer of at least one of these two objects, the emitter or the plane. In this case I'm going to change the layer of the emitter because Obi particles need to be in a separate layer than that of the colliders in order to generate collisions. Okay, so if we left the plane and the emitter in the same layer, no collisions would be going on. If we hit play now, we can see particles colliding with the plane but rolling right off because there's no friction at all. So what we are going to do now to fix this is give our Obi emitter a collision material. This one, medium friction, which is a default one, should be fine. And here we go, particles no longer roll off the plane. If you look carefully, particles aren't really sticking to each other, they're just, each one follows its own path, so this doesn't really look like a fluid. What I'm going to do is I'm going to change some of the parameters of our fluid material here. The first one that I'm going to increase is surface tension. Surface tension causes particles to stick together. So instead of 0.1, I'm going to use 1. The second parameter that I'm going to change is the smoothing length. Okay, a larger smoothing length allows particles to interact with more neighbor particles around them, so the fluid looks smoother, more fluid-like. So if we hit play now, you can see that things are looking much better. Okay, now if we wanted our particles to be smaller, instead of just big spheres, what we can do is change the resolution of our fluid material. Okay, so by default 1000 particles are used to represent 1 cubic meter of fluid. So if we increase the resolution, more particles will be used for the same volume, so our particles will be smaller because there are more particles in the same space now. So as you can see, now we have smaller particles. We could even go with even smaller particles, like this. Okay, but of course, the smaller your particles are, the larger the amount of particles you will need to represent the same volume of fluid. So this has an impact in your performance. We're going to keep it at 2. And I think we're pretty much done with the behavior of the fluid. What we are going to do now is render our fluid as an actual surface, not just a bunch of dots or particles. So in order to do that, we are going to go to our main camera and add a new component which is called Obi Fluid renderer. Okay, Obi Fluid renders the surface of your fluid using screen space splatting. Okay, this is a method that works in screen space, and unlike other methods like marching cubes, for instance, it doesn't create a mesh around your fluid particles every frame, so this is a lot faster, and most of the time it also looks better. So the fluid renderer asks us for some particle renderers to render, so I'm going to say, hey, you need to render this emitter here. And the next thing that we need to do is give it 2 materials. The first one is the color material, which determines how the colors of your particles blend with each other. So I'm going to use one of the default materials, which is fluid color blend, which is a blending mode, a multiplicative blending mode to blend colors together. And the other material, the second material, is the fluid material, which actually is in charge of rendering the surface of your fluid. So I'm going to use clear fluid, which is another standard material. And that's it. If we click play now, we'll see pretty much nothing has changed. This is because the particles themselves are obscuring the fluid surface behind them. So what we need to do is go to our Obi emitter and disable the render checkbox here in the Obi particle renderer. Make sure that you disable this checkbox and not the renderer itself, okay? Because if you do this, then you won't see any fluid at all. If we hit play now, we can see something going on here, but not much. This is because our particles are very small, so I'm going to increase the radius scale, and what this will do is increase the size at which particles are being rendered. This doesn't affect the simulation itself, just the visuals. So we could even go bigger, okay, as big as you like, but we are going to leave it at 2. If we change the color of our particles, the color of the fluid changes accordingly, okay. If we wanted the color of the fluid to be more intense or less intense, we could go to the material we are using for the fluid, which is this one, clear fluid, and here we have a thickness scale. If we increase the thickness scale, the color of the material will be more intense, okay. We can also control the refraction of it. I'm going to pause so that you can see the refraction. And we also have the smoothness of the surface. Okay, so that's pretty much all. Hope you have enjoyed the tutorial, and we'll see each other in the next one.